finger on the P. Class, where's the P? 6. And where's the Q? It's the first one. So P divided by Q, our last, divided by our first. Class, what are the factors of 6? 2 and 3. 2 times 3 is 6. What else?
6 times 1.
6 times 1. And the number in front here is a 1. Alright, so let's figure out all the numbers we need to test. 1 divided by 1 is? And this is a positive and negative 1. What's the next one? 2 divided by 1 is? So you're going to have a positive and negative 2. What's the next one? Positive 3 and negative 3. And the last one is? Positive and negative 6. Alright, I'm going to give you guys the bad news first. The bad news is we have to do this 8 times. 8 synthetic divisions. We have to figure out the ones that work. Here's the good news. You're already sitting in groups of 8, kind of. So in your area, you guys are going to separate and kind of assign each other a problem. Does that make sense? So instead of each person doing all 8, then only one person or 2 people have to do positive 1. You just test it with synthetic division. Okay? Someone be a leader in your group and then assign each other a problem. Ready, set, go. Alright. I'm going to call on a student, and it's okay if yours doesn't work out. I just wanted you to tell me what you did on your paper, okay? John R. What number did you test? Positive 3. John, tell me what numbers to write up here, please.
1, negative 7, negative 1, and positive 6.
Thank you. John, tell me what to do.
Bring down 1. Times 3 and put 3. And then 3.
And then you add those two. What do you get?
4.
Uh-huh.
You times them and then get 4.
Go ahead and add down. You can also think of it as 12 minus 7. You can think of it as 12 minus 7.
Can't figure it out.
So negative 7 plus 12 is 5. John, keep going.
5 times 3, 15.
Uh-huh.
And then 14.
If I multiply those two.
42.
And if I add those together.
48.
48. Thank you. Class, does that equal 0? So this is not a factor. That means that x equals 3, or the binomial x minus 3 will not be a factor. Okay? Alexis, did your number become a remainder of 0? It did not? And what number did you have?
And 3.
Same thing? Okay. Thank you. Brian M., what number did you test?
-1.
And did it work?
Yeah.
Alright, let's test it. So I'll write the same numbers. Bring it down. Brian, -1 times 1?
-1.
Brian, if you add those, what do you get?
0.
Multiply.
0.
Add.
-7.
Multiply.
7. Positive.
Add.
6.
Multiply.
-6.
Add.
0.
That means x equals -1 is a factor. Okay. It says rewrite the polynomial as a product of its quotient and linear factors. What does that mean? I need to write a number here. Class, should I write x -1? X what? X plus 1. Remember, if you forget, write an x in front. This was from your last quiz that we did. You guys are like, do I really need to have the x there? Yes, you do. X equals -1. And then if you add 1 to both sides, you get x plus 1 equals 0. That's why it's an x plus 1. Okay, here's the next question. What does that become? Talk to your partner in 10 seconds. How can you write this with your x's in there? Good job, Brian.
Oh, dang. Oh, no. Just erasing.
Evelyn, what did you write here?
1x plus 0x negative squared x squared, and then -7x plus 6.
Plus 6. That's correct. If I were doing the problem, remember this is your remainder, I would start with a constant, which basically means no variables, and just keep adding a variable x. Okay? Alright, so we found out that x equals -1 works. Okay, now watch this. In the blue, we're essentially going to do synthetic division again. I'm not going to write down these numbers. I'm going to write down the numbers in blue. 1, 0, -7, and 6. Okay? Angie, what number did you test?
2. Negative 2.
-2? Question. Did it work or it didn't work? If it doesn't work for this polynomial, it's not going to work for this polynomial. Okay? Thank you, Angie. Madeline?
-6.
And did it work?
No.
Thank you. Johnny?
-1.
And did it work? Jasmine, what number did you test? -3. Did it work? Let's do this together, Jasmine. Jasmine, multiply. Multiply. 3 times 1.
Oh, -3.
Add.
-3.
Multiply. Multiply.
6. I think it's
Add. Class, is it a factor? Okay, so let's review what we have so far. We have this x plus 1 works. Class, what do I write here? X plus 3. Remember, if you forget, x equals. And class, tell me what to write here. X squared plus 2. Which one of these is not factored? This is a factor, right?
No.
This is a factor. Class, is this factored?
No.
No. And then we can just use our what? You could use your rational roots theorem to actually pick the other one, or at this time you can also, will be appropriate, is use our x method of factoring. Let's do that really quickly together. Class 2, A times C? 2. B value?
3.
2 numbers that multiply to be 2,
2 and 1, or negative.
but add to be negative 3.
Negative 2 and negative 1.
Okay. So this should tell us something. Class, does 6 work?
No.
Does positive 1 and positive 2 work? Yes. And I'll show you to the very end how they also work. Last step. It says factor completely and solve. We talked about solving a little bit. Essentially what we're doing, give you a big picture idea, is we have this polynomial. You like my polynomial? And basically where it crosses the x-axis are our roots, or x-intercepts. And that's basically what we're finding. So now I'm going to set each of these equal to 0. Class, if you solve for x, what do you get there? Negative 1.
And then you have 1, 2, 0.
Negative 3. Positive 1. And 2. And these actually match all the numbers above that we tested that actually worked. Does that make sense?
Yeah.
So what is the rational roots theorem? The rational roots theorem is a way of taking our long polynomial and figuring out ones that are factors and ones that are not factors. If we do find a factor, it makes the polynomial in some ways, I wouldn't say smaller, but more workable, and then we can help us find other factors. Okay? And that's the rational roots theorem.